relationships. And I think the easiest way to understand them is if you compare them side by side. So the graphs, a direct relationship, a direct equation is going to always go through the origin. It can be a positive or negatively sloped line, but it's always going to be a straight line and it's always going through the origin. So you could have a line that's a straight line and it's over here, didn't go through the origin. So it's a linear function. Okay. It's a line, but it's not a direct relationship. Those are different. Okay. Has to go through the origin. Conversely, inverse cannot go through the origin. It totally avoids the origin. It starts coming down here, getting closer and closer and closer to the origin, and then it just like spins off. Okay, so they look like these funny little curves. There we go. Not a perfect drawing, but those would normally be a little more equal, but they're in opposite quadrants. They do not touch the origin. So if you go to look on a table of values, let's say you weren't given a graph. I mean, this is pretty obvious, people. Like, if it looks like that, it's direct. If it looks like this, it's inverse. Okay. But what if you had a table of values? Well, if the table of values had 0, 0 in it, I know that it cannot be inverse. No way, Jose. It cannot be an inverse because only a direct relationship can have 0, 0 in it. Okay. Now let's think about the other ways to note if something is direct and inverse, because you're not always given the graph. Maybe you're given the equation. Well, the equation is y is equal to k times x. So this looks very similar to slope-intercept, okay? With a slope but a y-intercept of 0, of course, because that's where it's crossing the y-axis. That makes sense. So the k value is called the constant of variation. It's how much the y changes for every change the x makes, okay? So that's the equation. That's what it looks like. And then this equation looks like y is equal to k over x. All right, so let's look at that. If we had numbers, so the k value is going to be the numbers. Here we can actually say the k value is the slope, because it is. But here it's not the same. We would not use the term slope to depict this k value. Let's go over to Desmos, and let's take a look at what these equations would look like. All right, so if I type in y is equal to 5x, do you see that's a straight line and it's going straight through the origin. So if I just type this equation in, I can determine if it's direct by looking at the graph. And conversely, you can look at y is equal to 5 over x and say, oh, okay, look, that's the blue line. That's two curves. But here's a trickier one. What if you had y is equal to x over a number like 5. Oh, well, that did something. Oh, I put w in there. That did something different than what I expected. I thought I was going to get the same kind of thing that I got in the blue lines, but actually this is a direct variation. Well, why is that? Because, first of all, let's change this to an x because that's what it really should be. There we go. Because this right here is equal to, it means the same as y is equal to, what is the little number right in front of the x? It's invisible, right? What is the coefficient of x? Well, it is 1, of course. So 1 over 5 with the x out to the side. Do you notice that those are exactly the same lines? Okay, so let me just show that. So if I make this purple line invisible, you see the green line is under it. So those two are exactly the same. All right. Now that it gets a little tricky. This is pretty obvious right here. But then once you start looking at the differences between these two, but if you're unsure, go to Desmos, type it in. Desmos will graph it for you, and then you'll know, oh, okay, that's what kind that is. All right, so now going back to this, we've got our two graphs and we've got our two equations. And then sometimes you'll also be given a table of values. When you are given a table of values, you are going to test those values. Now, one thing you could do is you could type your table into Desmos and look, is it a bunch of lines lining up and going through the origin? Lines, I meant to say dots, lining up and going through the origin, or does it seem to make this shape? Well, sometimes you can tell and sometimes you can't. So what we do with the numbers in the table or the ordered pairs that we're given is direct divide. So if I divide these two numbers over and over and over and over again, if I divide y by x over and over, and it keeps giving me the same number, same number, same number. So division worked to get the same number, same number, same number. First of all, that same number is the k, the constant of variation. And second of all, it is a direct relationship. Now over here, if I multiply x times y, so here I multiply. If you multiply the x times the y and the x times the y and the x times the y and the x times the y, and they all give you the same number, constant of variation is what that is. And if it's the same number over and over again, when you multiply, it is an inverse relationship. So let's look at an example. Like, what if I have -6 and 2? And I have 0, 0. Ooh, that's a big key, right? I guess this could be neither, so we'll just double check that it actually is what we were looking for. And 9, -3. Okay, so here's my ordered pairs. And if I multiply -6 times 2, I get -12. 0 times 0 is 0. 3 times -1 is -3. Is this the same number? No, it's not, -27. When I multiplied, I did not get the same number. So I'm pretty sure that this is not an inverse relationship. Let me check to see if it is a direct relationship. So 2 over -6, that equals -1/3. 0 over 0, well, it doesn't have the same k value or it doesn't have the same relationship, but we know that a direct relationship does go through 0, 0, so we're cool with that. Now, -1 over 3. Notice I'm putting the y value on top and the x value on the bottom. -3 over 9. Well, that equals -1/3, and that just is -1/3, and all of those reduce to the same thing. So this table of values is for sure a direct relationship. That is how you can determine that. I don't want to erase everything, but I do want to give myself some more space here. All right, so now what if we had a different set of values? Let's try, how about, okay, let's try these values. So let's say you're given a table and it's 1 and 40, and it's 2 and 20, and it's 4 and 10, and it's 5 and 8. Okay, well, if I divide those numbers, 40 divided by 1, that gives me 40. Okay, 20 divided by 2, that gives me, 10. These are not the same number. So division did not work to get me same number, same number, same number. Let me try to multiply. 1 times 40 is 40. 2 times 20 is 40. 4 times 10 is 40. And 5 times 8 is 40. You might even ask yourself, what would be another number that would be okay? Well, how about -5 and -8? How about you could even have -8, and you could have -5 on your y values. Anyways, all of these equal 40. So multiplying did work, and so we are satisfied that those values, this is a set of inverse values. What other situation might you come up with? They might give you a word problem. I think I should cover that in a different video. So hopefully this made sense to you. And that same number, same number, same number. Remember this time I got 40 each time. So where do I put it? I can write the equation of this table as y is equal to 40 over x. The last table, the same number I kept coming up with was, wish I would have gone back on that. Oh, I kept getting negative 1/3. So then you would say that y is equal to negative 1/3 x. And that's how you would write the equation based on given a table. Hope that helps. Stop and